Hello to all of you who are interested in learning the Python programming language. Thank you for being with me in another educational video of this powerful programming language. We go to the discussion of finding the largest and the smallest n items. You have a data structure with a number of elements inside. This data structure can be a list, tuple, dictionary, or set. How can you return, for example, 500 elements from this list when these 500 elements are the smallest among all the elements in this list? Let's at first consider a topic here. For this purpose, we need to make markdown this cell, make this cell as markdown. Actually, go on markdown mode, insert a square sign, consider a space, and write the topic we want, which is finding the largest and smallest n items here around the cell, and you can see the topic here. Okay. For the question arised, a simple solution is to use the features of the data structure. For example, a list. Consider a list which is named numbers containing some integers, positive and negative ones actually. For example, something like this. We want to sort this list and return, for example, the 3 largest members. At first, we need to apply the sorted built-in function on this list. And you can see that in this way, the elements in this list were sorted from small to large. Excuse me. We use a square bracket notation and slicing to return the last 3 members of this sorted list. For example, we can have applying the sorted built-in function on these numbers and use, for example, in this way we have the 3 smallest members of this list, and also we can have something like this in order to consider the 3 largest ones. Okay. Pay attention to a point. In cases where you have a very large data structure including a large number of elements and you need to work with a very small fraction of this number of elements and return the smallest or the largest using the basic features of the data structures, for example, as data structure like list, it is not very optimal, okay? Because too much time must be spent sorting that very large data structure. These methods are useful in cases where the difference between the total number of data in the data structure and the requested number of data is not such considerable actually. But in cases where this difference is significant, it is better to use a heap. What is heap? Heap is a data structure. Like the rest of the data, the data structures in Python, this data structure has a series of features too. This data structure is a binary tree data structure actually. That is, it has a tree structure. There are 2 types of heap, a min heap and a max heap. You can see some information about that in the internet. I come to the Twitter website, and you can see similar information on the internet too. Okay, this is a concept of a binary tree structure. You can see this here. In both of these, I mean the min heap and max heap, we have a root heap which is also called a parent heap. Here this is the circle containing 3 at the top. In min heap, this root has the lowest value among all values in the data structure, and in max heap, the value of this root is greater than the values of its children, which are actually other values in the data structure. This is the concept of a binary heap. Suppose we have numbers in a list and we want to put these numbers in the heap. We do not do this manually, but there are modules in Python for this purpose. But the main logic is that every element that is going to be added to the heap is compared with its parent, and depending on whether the desired structure, actually data structure, is max heap or min heap, and that the new value is less or more than the value of its parent, either the new value is added as a child, or it replaces the parent. In Python, we use a heap queue, which stands for heap queue algorithm. This heap queue is actually min heap. This min heap has different properties, and you can read about it yourself at docs.python.org. You can search it and become familiar with its wonderful options. Okay. We want to find the largest or smallest n items. At first, actually, we need to import the module, the structure heap queue. Okay. Let's again show the numbers. Let's have this heap queue and use some of its properties like n largest, because we want 3 of them. The first input argument should be 3, and the second should be the list which contains these numbers and elements. Okay, you can see the result here. Actually, this heap queue is another properties, another method which is n smallest, and again a 3, and the list name, and you can see the result here. Okay, let's make a list of dictionaries. In each of these dictionaries, we want to write the name of a company and its information. For example, consider we have a list of dictionary actually. Okay, we want to have name, RED, number of workers, for example 1000, and its price, which is here, for example 93.8. Okay, let's copy paste it to have some other rows similarly. For example, here the name, another company, for example EWS, number of workers 2000, and price 90, for example 0.8. And the other one, its name, for example TRE, number of workers 500, and its price, for example 100.8. PLE, for example 700, price for example 50 point, for example 3. The other one STQ, its name STQ, number of workers 580.4. Okay, consider that we do not consider any correlation between none of the pairs of these key and values here, and we just want to work with the data structure for our purpose. Now on this data structure, I want to extract two larger ones. Let's have this heap Q and largest 2 and D. You can see that we receive an error because with this line of code the interpreter does not know which input it should actually apply this function to. So we have to give it a key. Let's do it again. Heap Q dot and largest, again 2 and D, and this time we want to consider a key lambda, pay attention, lambda S where price. Run the cell and you can see the output here. This line of code returns the two companies with the highest price. The same can be done with n smallest. Let's do it. Let's have a copy paste it, and instead of n largest use n smallest. And you can see that these are the companies, these are two companies with the lowest, the smallest price actually. We can have the same arguments for the rest of the keys. Let's do it in largest. This time let's do it on the number of workers, for example. You can see the result. Let's do it with n smallest. Let's have the smallest number of workers companies. Okay, let's try it for name. Larger one, largest ones, and actually smallest ones. You can see that there is no error, although the name of key values are strings, are not actually numerical. If we do the same thing for name, it works according to alphabetical order. That is, it returns the name that has a larger index based on alphabetical order and is actually further away. Actually, the story behind the scene is that, for example, these numbers are a list, but if not, we could convert it into a list ourselves. Actually, a heap can work like something like this. If the numbers where not least heap can do it itself. One of the heap functions is heapify. This method converts lists into heaps. Another method of the heap is a heap pop, and it returns the last element in the heap, just like the function of pops in lists. It means that the smallest member is returned in min heap. Consider another list which has the same name, containing some positive and negative integers. Let's see what is the minimum of this list. Let's see what is its maximum. Okay, but if the number of elements we want is much smaller compared to the data size of our data structure, it is better to use a heap. But in cases where this ratio is not very low, it is better to use the facilities of the lists themselves. Now we will discuss the implementation of the priority queue. Let's have a topic here. We need markdown, a square sign, space, and we need to write the desired topic. Okay. In this situation, when using pop, not the last member but the member with the highest priority is returned. Let's do it again. We want to import heap queue. We want to have this collected together. Let's define a class. For example, PRQ. Self dot q self dot index is 0. We consider an empty list as a self dot underscore q. Let's define another function inside this class, which is named a push. As always, we need a self and two other input arguments, which are item and a priority. Heap q dot heap push. What should be pushed? In what the data should be pushed? In self dot q, and we need to consider the minus form of priority. And self dot underscore actually index, and the item which is desired to be pushed. Another thing which should be done is increase the value of the self.index one time and define another function inside this class, which is pop. We want it to return heap q dot heap pop self dot q. This is okay. Okay, the first letter of class was enlarged from big letter, and it led to it led actually to an error. These underscores are in the are here in the initialization function to are available, are here to exit the public mode. Actually, the reason for the presence of this -1 in the pop function is that we want the largest member and not the smallest. Remember that heaps in the Python are min heaps. Another method of a heap queue is a heap push, which sends the desired item to a queue. The reason for considering the negative sign inside the heap push for priority is that we want the largest members to be popped and not the smallest. Here this is the negative, this is the minus sign actually. The reason for considering self dot underscore index in heap push is to specify that if the priorities are equal, the item that entered the queue earlier will be added to the heap earlier. Okay. Let's have another class named item. Okay. Define a function init with input arguments self and name. Inside it we want to say that self of name is equal to name, and we want to have another function which is rep, related to showing the parameters inside the class. We want to say that return item. I will explain it further. Here accept it from me that you should write like this. First, create an object from this PRQ. We want to consider object Q as an object of this PRQ. Let's see what is the Q. What is the problem here? Let's see what is its index. there is the same error. Let's see that if other methods are working with it. If not, we examine it. Item, for example, A and 2. Okay, the problem, let's run them again, see if there is any problem. This is its attribute. Let's copy paste it. Maybe there is any type error. Okay, the error was because I forgot to consider this parenthesis, so the Q was not considered an object of the class BRQ. Okay, you can see that now the pushing item is done. Let's push some items in this object, for example B and 5. Okay, again copy paste, and for example option item 3 with the let's consider number 1 here. I will explain them the end, the same too. Okay, now let's show this Q, and you can see that this is not very understandable, but we can show its Q, and you can see that there is push, these are indexes. What are the problems here actually? Let's see what is the index. These are 4 index. With push, in the definition of a push function, we need an item and a priority. Actually, we considered these and the item is from here Okay, the problem was here. Let's again run all the cells for have in order to have okay. Let's show its Q, and you can see the output here. Here you can see that the item with higher priority is placed first, and now we want to work with the pop defined function. It returns the item with the highest priority as we had planned. Again, let's do it. Apply the pop function on our object. Pay attention that A and B both have the same priority, but since A entered earlier, A is returned. Considering that these heaps work with O log n complexity order, actually order of complexity, they are very efficient for large data. Now let's consider A is equal to 5 and 0, and for example an object from item with the name A, and B is a tuple with these input arguments. Let's check if A is smaller than B. Okay, there is an error because the interpreter does not know that it should apply this less or smaller function on which of these numerical values. Let's consider the second one. Do not consider the second one for now, and check this, and you can see that this is false because 5 is greater than 2. But if we consider a C which is 5 and 2, and for example item C, this time if you want to check, for example, A is less than C or not, you can see that there is another error because these are not appropriate for this purpose. We need another argument here. Actually, if we consider A like this and again run this, you can see that this is true because the first elements are equal, so the second ones are checked. So you can see the effect of this priority index and item here. Here we consider that this priority numerically. This priority can be a parameter from somewhere else. Let's go to the discussion of key mapping to several values in a dictionary. Mark down. Key mapping to several values in a dictionary. Okay. We have already already seen that it is not necessary to map each key to a single value. Here we want to mention a series of easier methods to make this. Let's consider a dictionary like A, which is 1, 10, 20, 30. $100 and $300. Okay, and let's have another one which is named S. And these are the same, but S is not but here the values are not lists, they are sets. Okay. Let's show D and S in separate cells. This is D and this is S. Okay. You can create such dictionaries using the facilities inside the collections module. There is a method in this module called the default dict. Of course, at first we need to import it. The keys values are going to be put inside the list, so we should have the default dict, and inside this we need to specify this list. Now we want to use the square bracket notation that append 10. Okay. Copy and paste and consider another member of the value list, another one which was a 30. Okay, and the second key and its value which was 100, and the second key and its value which was 300. Okay, now let's go this D. Okay, this is the D. Now let's have the S with the default dict. This time we need set, and now we want to have S, a square bracket notation, the first key dot, this time add 10. Okay, the second parameter of the set value was 20, and the third one was 30. Now let's consider the second key, and its value is 100, and this is 2, this is 300. Okay. Let's show that too. Okay, sets do not have append like lists, and you must use add. Pay attention to a point that you know that when you create a dictionary you also need to initialize it, but here default dict does it by itself. In some cases this feature is desirable, and in some other cases it is not desirable, so you should pay attention to this point. If this feature is not desirable, you can use a set default. In this method, considering the empty list is actually the same as initialization. Let's try it. Consider an empty dictionary and act like this. Set default 1, an empty list which is the same initialization, and now append 10, and you should copy paste it for the other ones too. Okay, a T letter is missed here, so the error was because of that. Okay, the second one which was 20, the third one which was 30. Now let's append the second key and its values, and like this. Okay, 300. Okay. The set default function may seem strange because it needs to consider this empty list in each command, but anyway this is the set default function. Now let's show this D and you can see it. To understand the difference between these two methods, pay attention to the pieces of code that I write. I want to consider another actually empty dictionary for this D and say for kind we in a pairs. For example, if con nothing D square bracket notation, consider an empty list, and again with this consider with this square bracket notation apply the append of function of with it. And if I want to use with work with default dict, I should act like this. Default dict with input argument list and say for kind we in a pairs, for example, append to deca this way. Okay, so it is more optimal to use a default dict. You can see that the corresponding code is shorter. When these codes are going to be repeated thousands of times in your program, this optimization becomes more apparent. Thank you so much for watching another tutorial videos of Python programming language. I highly recommend you that stay tuned since very noticeable and practical tips are awaiting for you in the upcoming lectures. Have a nice day.